In this video, we're going to talk about the list interface. So a list stores elements in a sequential order. So that's the defining characteristic of a list, is that it keeps an order, and it allows users to specify where the element is stored if we want to. And we can access the elements by index. And just so we're clear, we're talking about the list interface right here. So the list interface implements the collection interface. So it has all the things that a collection has. And then there's an abstract list that implements a lot of the methods and actually writes those methods for us. Because remember, an interface doesn't actually write the methods. The abstract list adds a lot of the methods, so they don't have to be rewritten in these classes down here in LinkedList and ArrayList, which is where we're headed. We're kind of tracing down through the chart to get down there to those things. Okay, so let's look at the list interface. The list interface adds a method for adding an item at a certain point at a specified index. Remember, we had an add that was required by the collection interface, and now we've added another method called add that actually lets us add something at a certain spot. We can add all the elements. We can get a specific item using an index number. We can get the index number of a specific item in the list. We can get the last index of a particular object in the list. And we can also use a list iterator. So the list interface requires all these methods. In addition, there's a list iterator, which adds some options to the iterator that we talked about before. This one specifically, an iterator for lists, has a method to check previous entries to see if it has a previous item in the list. We can add an item to the iterator. We can get the next index, find the previous item or the previous index. So the list iterator, we'll see examples of that in just a minute. So that exists too. It kind of goes in a pair with the list interface, the list iterator. Okay, now we're jumping down in our chart to the actual ArrayList and LinkedList. We're going to take a look at those. So the ArrayList class and the LinkedList class are concrete implementations of the list interface. By concrete, it means we can actually create an array list, which we've done in the past, or we can create a linked list, and we're going to see how to do that in a minute. These are the concrete classes. Remember, everything up to this point has been interfaces and abstract classes, and we can't actually create objects from them, but they all supply things for the actual concrete classes of ArrayList and LinkedList. So these are the two things that we'll actually be using with all those other contributing classes or abstract classes and interfaces that contribute to those. Which one of the two classes we use depends on our specific needs. If we need to support random access through an index without inserting or removing elements from any place other than the end, ArrayList is very efficient. So if we need to be able to pull out something from anywhere in the list and we just basically need to add elements onto the end of it as we need to, that's a really great way to go. We want to use an ArrayList. It's very efficient. But if our application requires the insertion or deletion of elements from the beginning of the list, we should choose a linked list, because a linked list is more efficient at those. So all lists can grow or shrink dynamically. However, an array is fixed once it's created. So if our application doesn't require insertion or deletion of elements, that's when we just use an array. Now, one thing to know about an array list is behind the scenes, it does use an array. And if you remember, an array is fixed, and if we add an item to an array, well, we can't add an item to an array. So what an array list does is encapsulates the array, and when we add an item, it creates a new array with all the elements of the current array and adds the item onto our array, and then deletes the old one, and it does it all for us behind the scenes. So an array list is an array that can grow and shrink. Behind the scenes, it's still using an array. So here's the array list. Remember, ArrayList implements the list interface, the Java utility list interface. It implements the collection interface, and this is the concrete class. And if you remember, there's also an abstract list class in between there. So we have a constructor for an array list. We can create an array list from any existing collection. We can create an empty list with a certain capacity. And we also have this trim to size. So an array list can shrink. We can add things to it. We can delete things from it. But it doesn't actually shrink the array behind the scenes unless we run this trim to size, and it will shrink it down and free up that memory. But that's in there. For small lists, you can almost forget about this a lot of the time, add and delete things. But if you're trying to optimize your memory, it does pay to trim the capacity of the array list. If it's had a lot of things added to it and then deleted, you can do that. A linked list also uses the collection interface. It also uses the list interface. We have a constructor to make a linked list. We have a constructor that will take any collection and turn it into a linked list. And we have some methods that let us add things onto the beginning of the linked list or the end of the linked list. We can also get the first or last item from the list. And we can remove the first item from a list. So these are all the things that a linked list provides. Okay. So linked lists really specialize in adding and deleting things off the beginning and ends, where an array list allows more random access. We can put things in the middle. We could put things at the beginning if we wanted, if we were doing a lot of beginnings and endings. We pick a linked list. If we just want random access and we're constantly adding things onto the end, array list is the better way. So let's look at some examples. We're going to see an example that creates an array list filled with numbers, inserts some new elements into the specified location, and then we're going to see a linked list made from that array list, and then we'll insert and remove elements from the list, and finally we'll see an example of how to traverse the list forward and backward using an iterator. So let's take a look at that code. Here is the code. So we're creating a new array list right here. It's going to be a list of type integers. We're using a type diamond. Notice we could have used array list here, but we're just using list. It's fine. It doesn't hurt anything at all, but it's still creating an array list. So we're adding the, since it's holding integers, we're adding 1, 2, 3. We're adding another 1, a 4, and then at position 0, we're adding in a 10. And then at position 3 or index 3, we're putting in a 30. So those add methods let us specify an index. Okay. And then printing out a list of integers. And we're just print line and we're passing the object name array list into it. Okay, so that's an array list. We've seen that before. We've done it. Not a big deal. Now we're going to create a linked list, and this one, it says it's of type object. And we're going to create a new linked list, and we're passing in the array list. So it's going to take that array list and turn it into a linked list. Okay, and in this case, we're adding the item at position 1. We're adding in the word red. Now, how can we get away with that? How can we add a string to that linked list when it started out as integers? Then the answer is that when we created the linked list, we said it's just going to hold objects. The ints are objects, or integers are. It uses auto boxing to create integer objects from our ints. But strings are also objects. So in this case, it's inserting some words into this linked list. We have a remove last that's taken the last item off the list. And we have an add first that's adding green right onto the front of the list. And now we're going to see some examples of using list iterators. So we print out, hey, let's display this list going forward. and we create a list iterator based on our linked list iterator method. We'll create the iterator for us. And then we can use the iterator's hasNext method. And as long as the list iterator has a next item in it, so as long as there's another item, we're printing out that item with a space. So it'll run through as long as there's a next item, it runs from the beginning to the end. Now this one, because it's a linked list specialized in going forwards and backwards in this case, it's technically a doubly linked list. This one, we're creating a list iterator that starts at the end of the list. And the way we make it start at the end of the list is say, hey, we want to start at the size. So it's starting at the end of the list. And now we're checking to see if there is a previous item in the list and printing them out. So this prints from the end to the beginning instead of this one, which printed from the beginning to the end. And I can click the button in this example to bring us over. This is the actual code in an editor that we can run, and it's already ran it for us. So list of integers, remember it added the 10 at the beginning. When we created it, it added 30 at this position. So there's our original array list of numbers. Okay, and then we created a linked list from it and added the red and green, so you can see green and red that got added using those methods we talked about. And we display the linked list, and they got a typo here. This is creating the list forward, and then this one is the list going backwards. They called both of them backwards, but technically this one's forward and this one's backward. And we can see that up here. This one's forward, and this one has previous as backward. So that's just a typo on their part, but that's how they work. So linked lists, use those when you're adding things and removing things from the beginning and ending the lot. They're very efficient that way. Array list, use an array list when you need random access to items inside the list. You're mainly adding things onto the end. You're not doing a lot of things removing beginnings and endings. And if you're not growing and shrinking, you shouldn't use a collection at all. You should just use a regular old array.